Okay, welcome once again to my channel. Today we shall be looking at a problem on frictions. The question says, from the above figure, find the following: the acceleration of the masses, tension in string, and then the reactions. In this kind of problem on frictions, there are things that should always be remembered. Number one is that this tension here is as a result of this body that is being connected to a frictionless pulley. This is called a frictionless pulley. This body is connected to this pulley, and this thing is also connected to a mass here. Okay, things like this are always being asked in some examination like JAM and WAEC, stuff like that. And here we're going to start by something like this. Okay, normally if this mass here, remember that this mass is also affected by gravity. That means gravity is having influence on this mass. Okay, if this mass is higher than this, okay, as you can see, it's moving downwards. That's why this arrow is pointing down. Okay, so we can conclude that M2G, okay, which is higher than this tension, is equals to what? M2A. Exactly. That is the mass here, this mass times the gravity minus this is equals to, remember that MA, okay, MA is like, it's a force, so mass times acceleration, so that is a force that is causing this thing to to move upward. Okay, now this is 6 here, so 6 times G is 10. Okay, then minus T is equals to what? 6A. Okay, now this is going to give me 60 minus T equals to what? 6A, right? So I have that 60. Okay, if this comes to this place, I have 60 minus 6A equals to what? Equals to T. Okay, I call this equation what? Equation 1. Are we there? I call this equation 1. And also this one is regarded to be our M1. Okay, so M1G, this M1G is, let's just put it ahead, as in this tension here minus M1G, okay, sine theta, right? Sine theta is equals to what? M1A. Okay, this is, we can do something like this. Okay, so the vertical component of this, okay, the vertical component, right, multiply by this mass times the gravity. Okay, if we take it away from this, it will give us the force that is pulling this, that is taking this into this way. So this means that T minus 2 times 10 times sine who the angle is given here, sine 30 degrees, is equals to what? 2a. So we have t minus 2 times 10 is what? Is 20, times sine this is what? 0.5, is equals to what? Is equals to 2a. Okay, and this minus this, that is t dash is minus 10, is equals to 2a. So t is equals to 2a plus 10. Is that clear? So we can call this our equation what? Equation 2. If I equate 1 and 2, okay, we will be having something like 60 minus 6a to be equals to what? To be equals to 2a plus 10. Okay, so this is going to give me minus 6a, okay, minus 2a to be equals to what? 10 minus 60. We are collecting like terms. Minus this will give me minus 8a equals to what? Minus 50. Okay, this minus will cancel this, so a is going to give me 50 over what? Over 8. 50 divided by 8 is what? It's giving me 6.25 meters per second what? Square. That is the value of what? Of our acceleration. It was 6.25. okay, now to get your tension, take this to any of these equations, okay, of this and this. So b, our tension, let's say from equation what? From equation 2, from 2, okay, we have that t is equals to what? 2a plus 10. Okay, we have t to be equals to 2 into 6.25 plus what? Plus 10. So t is equals to what? This times this is what? 25. Okay, it's giving us what? It's giving us 22.5 Newton. Okay, 22.5 Newton. Remember that tension is in Newton. Okay, and in physics it's not only force that is in Newton. Okay, there are other quantities that are also in what? In Newton, like tension, reactions, effort, load, all that. Okay, and the next thing is what? Is for us to get our reaction. Okay, our reaction, let's use this space. Our reaction arrow is equals to what? 2t. okay, reaction is 2 times 10, the value of tension. The reaction is equals to what? 2 times 22.5. so reaction will be equals to what? Equals to 45 watt Newton. Okay, so with this we've been able to come to the end of today's video. If you find this useful, please subscribe to our channel and share it with other scholars. Thank you.